Welcome back. Today we're going to talk about source code repositories, and specifically we're going to cover two frameworks, the Git framework and the Subversion framework. We're going to talk about the pros and cons of each approach, and this lecture is going to lead into a hands-on exercise in class where I'm going to show you how to set up a source code repository and start a repo of your own for your project this semester. First, let's talk about why you need a source code repository. Well, you, as part of a software development team, need ownership over your code. There are various ways that you could share your code back and forth within each other and create a production build. You could have one dedicated computer that always has the master code on it. You could email your code back and forth, but such systems are tedious, slow, and way too error-prone. And so, as a result, source code repositories were born. I just want to point out, in case there's any questions about this, a repo is just a short word for saying repository. So source code repo, or just saying a repo, you can assume that what's being applied is if I say the word repo, I mean the source code repository. So, if you didn't have the ability to have a source code repo, how might you collaborate with other people? Like I mentioned before, emails, having a centralized server that you always have the master code on and transfer your code individually to could be a way of doing it. You could collaborate who's working on which files. That way you never collide, meaning that you never try to edit the same file in two different ways. Maybe if you weren't using modern source code version control software, VCS, it's another word. It's actually the actual software that controls the source code repository is called a versioning control software. If you didn't have that, you might use something like Google Docs. But obviously there's way better tools out there now, and I'd like to show you what they are. Okay, there's two models, and there's 5 main vendors, but they all fall into these two models that the two frameworks that we're going to talk about today. Again, this is Git, and this is the Subversion framework. Off the top of my head, some of the main systems, your vendors you're going to see out there for versioning control system, Team Foundation Service, GitHub, Bitbucket, stuff like that. But they all fall within, while they all have their nuances, they will always fall within these two frameworks, the Subversion framework and the Git framework. Let's talk about the Subversion framework first. So it's a client-server architecture, meaning that the truth in your software, the ground truth, has a defined location. That's on the server. Whatever's on the server is always the truth. You have a local working copy of what is on the server that you can manipulate and work on your computer. So this is what we would call a centralized version control system, meaning that the entirety of the code, the truth, is centralized on the server in the Subversion approach. It's evolutionary because this was designed to meet the needs of a large community. The commands in Subversion specifically were designed so that you could tweak and modify the way that Subversion works for you based on the way that you're working on a project for your community needs specifically. If you know what Team Foundation Services is, it is a software that is actually a part of Visual Studio that was the source code repo for Microsoft before Azure DevOps launched. That was based on the Subversion framework. So it had a centralized ground truth approach. It has flexible branching, it has incredible branching capabilities, but it is monolithic. That is its main downside. And so the downside of it being monolithic led to the creation of Git. Specifically, people who were developing various Linux flavors had a need for a non-centralized ground truth approach to development. And so they spawned off this new type of versioning control software that is now lives on as Git. Git is different than Subversion. Its primary difference is that it is not a centralized, distributed approach. It is a peer-to-peer approach. That means that the ground truth doesn't necessarily live in any one file or spot or location. You have to actually look at the overall map to understand what the ground truth is. This is much easier shown visually when we do our lab in class. But this was revolutionary, as I mentioned before. It was particularly apt for the Linux model, where they were developing multiple flavors and dispatches of Linux. Its key advantage is that Subversion has the flexible branching, but GitHub has the better merging capabilities. and it's also extensible because it can be tweaked to meet the needs of a local group, because you don't have that kind of a centralized truth approach that Subversion does. You can tweak certain little sections of it to meet the needs of a smaller group of communities without impacting the integrity of the overall source code repository. So some terminology that applies to both that I'd like to introduce you to. 3 words in particular. So a diff is just a tool that you use to show the difference between 2 or more files. A branch is a way to indicate that you're about to explore a new feature set or something like this in the software. That's typically what it's used for. It's branched or forked. And so that essentially allows you to play with an independent version, play with that branch or fork independently of having your production system, so you can modify files in that while also having another test bench or production system that isn't impacted by the changes that you're making in that branch. Finally, we have the word checkout, which essentially just means that you are creating a local copy of whatever is on your versioning control system locally on your computer to work on. Okay, additional terminology. Conflict, that means, for example, let's suppose that you were working on an assignment, you checked in that assignment, but then into the source code repository, but then you made a change to the introduction paragraph and I made a change to the introduction paragraph. Well, when we both go to check in, we're going to have to resolve which changes get taken. If we're lucky, you change the top part, I change the bottom part, and there's no conflicts, and we can find a way to reconcile everything fairly easily. If there is a problem and we both modified the same sentences, let's say for a grammatical error, but we modified them in different ways, well, that's a conflict, and we'll need a way to reconcile that. You use the diff tool to resolve conflicts. Now some terminology that's specific to Git. We have pull. The pull terminology, what that does is it copies revisions from one repository into the other. The direction of the pull depends on where you're standing. So if you are using the Git Kraken client and you say pull, you are pulling from the GitHub. You're pulling from GitHub. So it means you're copying the revision from GitHub. Finally, we have tag, which is just essentially a way to put a certain snapshot in time of your overall code, and that can consist across multiple files. Okay, so how does Git track changes in files? I think it's pretty obvious the way Subversion with a centralized approach tracks changes in files. It simply does a checksum comparison of your copy, your local working copy, with the server's copy. GitHub with a peer-to-peer approach doesn't necessarily have that advantage. And so behind the scenes, what it's doing is, if you look kind of at this picture, it's using a secure hash algorithm to check to see if kind of the map that you've got on your working branch is similar to what it sees on one of its branches in the peer-to-peer network. So that's really all I have for this lecture. So I'll see you guys in class, and I look forward to putting together your first GitHub repo.